The way to build the Pareto formula in practical terms is as follows. First, we want to get point A. And for that, what we have to do is to solve the model and get the maximum return we can get. So we maximize our return and we will get a point within this vertical. We don't know exactly where it will be, but it can be up here, down here, or we can reach this point A. And to make sure we're getting point A and not all the points that are those which correspond to a large risk for the same return, we have to solve the model again, and we have to bound the return. So we want to impose that return must be at least this R max, and we want to minimize risk so that we know for sure we're going to get values in this vertical, but we want to minimize risk, so we will end up getting point A. Okay, we cannot get solutions beyond that vertical line, although we have reached a return larger or equal to our max, because we know for sure that there aren't any solutions that are in this area with a return larger than R max, so we will get all of them in this vertical line, and we want to minimize the risk and get this point. Similarly, to get point B, we will do something which is the symmetric approach. We want to first minimize risk, so we will get a point within this horizontal line. Okay, imagine, okay, we get a solution somewhere here. Okay, so we get the minimum possible risk. Okay, but we are not getting the maximum return we might get, because if we are here, we would prefer to move to our right and get to this point B, which is the one we're trying to get, because we have the same risk in this horizontal line, but if we move to B, we get a larger return for the same risk. So once we get the minimum risk we can obtain, next thing is we solve again, and in this case, similar to what we did, we add a constraint, we bound our risk so that we don't allow our risk to go beyond that level. Okay, and in addition to that, what we do is to maximize our return. Okay, so that we are not getting any solutions in this area below that horizontal line, although we wrote risk less or equal than k mean. Okay, because we know that this is the minimum value we can get. And what we are sure is we're going to, accordingly, we're going to get solutions in this horizontal line. And as we maximize the return, we will move towards B point. So with that two pairs of solves, we get points A and B. And now we want to explore the rest of the curve. So one way to do that is to get other Pareto solutions to bound risk or return and optimize return or risk. So, for example, I can impose, let's go with the first one, bound risk and optimize return. We can say, okay, I don't want, I'm going to write here, let me get solutions that have, this is supposed to be a horizontal line, okay? So I cannot go with solutions with a larger risk than this. So I only allow solutions to be below that horizontal line. So which is the best solution I can get in terms of return if I bound the risk? So I would be moving along this horizontal line and I would get this point here. Okay, so now I change my bound for the risk and I again maximize return. So I would be moving along this line and I would get this solution and so on. Okay, that is one approach. And the other approach is, let's paint it in blue. It's okay, I'm going to optimize with bound return and optimize risk. So in this case is similar to this. I'm going to impose a minimum return I want to get. So I'm only exploring solutions that are to the right of this vertical line that imposes a limit on the return I'm going to get. So once I do that, what I do is to minimize risk. So I'm moving down this vertical line till I get to this point. Okay, if I said could by chance get something which is similar or in the area we obtained first. So we want to get the solution which has a return which is at least this imposed by this vertical constraint line, and we want to minimize risk, so we would move down this line till we would get this point here. So if we repeat the process several times, we get several points, and we can go from this. For example, if we are using the second approach, we bound the return starting with the maximum return you can get for the minimum risk. Okay, and then let me get back to my uh, um, okay, no more pen. Okay, you can go all the way from the maximum return you can get for the minimum risk. You move to the right till you get to the maximum return. You pick a series of points here, and you repeat the process for each of those, and you get different points of your Pareto curve. Okay, you might not be interested in exploring the full front, but just an area around where the preferences of the decision maker are. But you don't have any idea, you can do that. Sometimes this is to solve because it doesn't take much time. Sometimes for complex problems, it can be very demanding in terms of computing time.